Hi, everybody. Thanks again for tuning in to another Water Issues Talk. Today we have Heather Johnson from MDA with us. Heather has been with the Minnesota Department of Agriculture since 2006 now and has been involved in stream monitoring in mostly southeastern Minnesota and has done a lot of pesticide monitoring, involved in numerous write-ups of MDA's pesticide data, including the annual report published on MDA's webpage every year, and has been involved in a variety of special projects as well. Prior to her time with MDA, she has worked for local, state, and federal organizations focusing in on water quality and water quantity issues. She holds a BA in Environmental Studies from the University of Minnesota Duluth, where I hearken from, by the way, and an MS in Water Resources Sciences from the University of Minnesota. She enjoys spending time in the outdoors with her family, kayaking, and planning their next national park adventure. Sounds great. Heather, take it away. Great to have you with us.
Hey, thank you, Mark, and thank you for everybody. I know I'm probably getting people who aren't out on a field day today because it's raining, so I appreciate you tuning in. Let me bring up my presentation here and get started. In case anybody's wondering, my next national park adventure will be, we're going to Acadia National Park out in Maine this September. So if anybody has any tips, let me know because it looks pretty exciting, but we've never been that way before. So like Mark said, my name's Heather Johnson. I'm a hydrologist with the Department of Agriculture. I'm trying to hide my video here so I can't see myself, but it looks like I might just be down the corner. Okay. And I am talking to you today about detection of cyanazine degradates in groundwater in Minnesota. I am building off of some work that Jill Trescott did. She talked a few weeks ago about some of the work that they've been doing in Dakota County about cyanazine. And now I will just be kind of expanding off of that, talking about what we have been doing with Department of Ag. So I will be talking about kind of the historic cyanazine data that's across Minnesota groundwater. Then I'm going to go through our current monitoring results from 2019 and 2020, kind of give you a flavor of what we're seeing. And then I'm going to spend a chunk of time just talking about what we are considering and what our plans are for monitoring for 2021. So here we go. So cyanazine is a triazine herbicide. It was used extensively to kill emerging broadleaf weeds and grasses in crop fields, including corn, peas, and beans. So one of the most common herbicides containing cyanazine was the latex, which is shown in this label here on the screen, and it was used from 1971 through the 1990s. So registration was through the Shell or DuPont company, and it was voluntarily canceled in the US in 2000. So it couldn't be used or sold after 2002 because of potential unreasonable adverse effects on the environment risk. However, as shown by this label right here, it is still being used in a few places around the world, including being widely used in Australia, of all places, with this being the latest label. So I did do a little bit of exploring. I contacted several scientists actually in Australia to ask if they had been seeing any cyanazine degradates and what the latest was from them. And it was fascinating because they don't do a lot of water quality monitoring. Pesticide results were very minimal, and they just had, I think, 3 results countrywide for cyanazine and nothing on the degradates. So again, just sometimes interesting when you can do a little exploring like that and learn about what was happening with this chemical elsewhere. So looking nationwide, this graph presents data from the use of cyanazine from the USGS Pesticide National Synthesis Project. So the corn is shown there in yellow and the cotton in red, and this is shown in millions of pounds annually. So the peak of cyanazine use in the 1990s was in 1994, and then it starts to trail off into the late 1990s when the product was canceled. And then this map on here on the right, you can see that this is now showing usage in 1992. So going back to that chart, you can see this is, you know, pretty big time of this cyanazine being used. You can see that the use was really focused in this Midwest Corn Belt area. Minnesota was noted as having over 14 pounds per square mile of use. And then also there was use down in that California area and along the Mississippi River Valley. Now, looking specifically at Minnesota, this is a data set that starts in 1990 and goes through 2000. So in 1990, there was an estimated 3.5 million pounds of cyanazine being applied per year. But as the 90 goes on, again, it trails off. But in comparison with today's use of herbicides, this would rank in probably the top 3 or 4 behind pesticides such as glyphosate, acetochlor, and metallic. So this graphic is one that we were using USGS estimates of cyanazine use, which was a total over a time period. And here the time period is 6 years. And this is based on the National Agricultural Statistics Service, or if you guys are familiar with NASS, data by county. So ideally, I mean, I would love to show you this from the 1970s through like 1996. But the NASS data only goes back to 1992. And honestly, we just haven't found great use records back earlier than the 90s. So like it's, again, so this focus is just looking at 1992 through 1998. So this kind of just gives us a general indication again of where use was the highest. And this is using normalized per pounds per square mile. So you could say it was widespread in the southern part of the state. You know, the most use based on this data shows that it was in the southwest and the southeast areas. So this map is potentially, and other ones that we've made, could be useful as we look to target areas for monitoring. So let's talk about the chemical itself right now. So 5 cyanazine specific degradates have been identified. And this graphic up here, while busy, does indicate the breakdown of the parent cyanazine, which is shown up here in this blue box. Now, cyanazine is an atrazine molecule with a cyanide that's tacked on its side through a triple bonded carbon and nitrogen. So this is why atrazine and cyanazine share some of the same degradates, which I'll be talking about further. So the 5 cyanazine degradates are these diethylcyanazine, the diethylcyanazine amide, cyanazine amide, cyanazine acid, and then the diethylcyanazine acid, which is shown right here. Now this one is the most frequently detected cyanazine degradate in groundwater. And then as well, we do have these 2 degradates, the desylpropylatrazine and the diethyletrazine, which are also degradates of atrazine. So, so now I've told you about there's cyanazine, we have these 7 breakdown products. Why do we care? Well, we're looking at it because total cyanazine has an established HRL. So just to review, HRL, or a health risk limit, or HRL, so you'll probably hear me say those 3 different ways today. It's a concentration of a groundwater contaminant or a mixture of contaminants that can be consumed with little or no risk to health and which has been promulgated under rule. So an HRL here is expressed as a concentration in micrograms per liter. So I'll be showing the HRL for total cyanazine shown as, oh, and let me show you this, what it is. I'll be showing it as the 1 microgram or the 1,000 nanograms per liter. So because there is really limited toxicity information on all of these degradates, all 7 cyanazine degradates are added to compare with the total cyanazine health risk limit in Minnesota, which is this 1 microgram per liter. So I should, before I go on, talk about, there are some nuances. Of course, nothing's ever quite as straightforward. Based on the MDH's guidance, which is, there's a hyperlink right there. If that diethyletrazine and the desylpropylatrazine are found in a sample, but there's no cyanazine degradates found, then you actually wouldn't use the cyanazine HRL, you would use the atrazine HRL. Isn't science fun? So that's something to keep in mind as we look at these samples. We're always trying to gauge, okay, we add in those two or do we not? But the focus of today obviously is on the total cyanazine. But this is not a unique thing. Total atrazine is also atrazine plus the sum of the degradates. So the takeaway from this slide is when you detect several of these compounds in a sample, you know, you're not just looking for cyanazine. Now you're looking for all of these degradates. It obviously takes less of any of those individual compounds then to exceed the standard. So looking now to work that has been done, historically, only the USGS Organics Geochemistry Research Lab, or the OGRL, had an analytical standard and method to test for cyanazine degradates after the product was canceled. Their method reporting limit was around 20 nanograms for all the degradates, but unfortunately, this method is no longer available, and I will go into this a bit further into the presentation. But in early 2019, the MDA contracted for the synthesis of cyanazine degradate analytical standards, and they are now available from 2 different suppliers. So with those standards, the MDA lab developed a method. So we use the SPE, which is a solid phase extraction. And our method reporting limit is between 10 to 25 nanograms per liter for the degradates. Now, WEC laboratories, which MDA used to run samples for our phase 1 of our private well pesticide sampling project, could also do this analysis starting in 2019. Now, their method is a little bit different from the MDA lab, but they were able to use our methods to develop their methodology on their instruments with similar method reporting limits. So I would be remiss if I didn't first mention the importance of the work that Dakota County Environmental Resources Department has done. They have been collecting and analyzing for cyanazine and its degradates since 2002, and they've been sending their samples to the USGS OGRL. And now they recently published on their website a final report for a 20-year study they've been doing, and all of their cyanazine results can be found there. And I'll be picking out just a few of those graphics to look at a little bit further in just a few slides. But to kind of give a historical perspective, in 2004, MDA tried to develop an analytical method, but we were unsuccessful. Recoveries weren't great, and they were not up to the standards that we set for approving any type of data results, so we just couldn't approve those degradates on our machines. However, we did collect samples from our groundwater program that year and have them run through that USGS lab. For the most part, sample results indicated really low values. And the MDA continued to look at results from Dakota County when they were available and track what was happening over time. So this graphic presents the Dakota County Environmental Resources data plotted over time as total cyanazine concentration. Now again, all this data here is from the USGS lab. And remember that red line right there shows the health risk limit of the 1 micrograms per liter. So one more time, I just want to say Dakota County deserves a lot of credit for continuing to look for this compound, especially when almost everybody else had stopped looking for it once the registration was withdrawn. So in general, when we had been looking at these graphics, we felt like it suggests declining concentrations, but up until 2017. That year, Dakota County conducted a targeted sampling of additional wells in areas where cyanazine degradates had historically been detected. So results from that 2017 sampling made available to MDA in late 2018 definitely showed that total cyanazine concentrations were rising, which prompted the MDA then to take this closer look at the cyanazine degradate issue. So here's a map. I wanted to point out again, so here's some just graphics from the Dakota County Ambient Groundwater Study Report. So this graphic right here shows results for total cyanazine from 281 locations from 2009 through 2019 in Dakota County. So they noted on this graphic that there are different zones of cropping, which I thought was interesting. And the vast majority of the wells here for the total cyanazine over that HRL were found in this zone 3, which maybe you can see my arrow, maybe you can't. But that was noted as intensive cropping. And the 3 townships, which aren't showing up quite as well here, with the highest total cyanazine concentrations were Marchand, Million, and Nininger. So you can see, well, they have collected samples kind of throughout the county. The cyanazine does seem to be fairly concentrated in several specific areas. I will say, as we started delving into the cyanazine degradate issue, we did pull in our incident response team, and they did a thorough look, seeing like, hey, is this just something where we had point sources that haven't been identified, or things that we need to go back to? But systematically looking through all the work that they have done in the past, there was nothing that pointed at like, oh yeah, that's a huge cyanazine point source. So we knew that this is, we're very confident this is not a point source issue. This is something definitely coming from the use that was used as application for farming, and has then just continued to become an issue as the years have went by. So here's looking at roughly here now 75 wells worth of data. This is also from that ambient groundwater study report. I thought this was interesting, just looking at the well depth. So this is looking at well casing depth. Nothing really jumped out about this, but a couple takeaways is that this median does indicate that total cyanazine is below 50% of the HRL in these shallow well casings and continues to drop. However, those maximums, you don't want to see that. So those are all over the HRL, and it's indicating that this is traveling down the deeper wells. So I just wanted to show this because I have a much bigger data set that I'm going to show you from Southeast that will kind of do this comparison of where we're finding these higher total cyanazine concentrations. Now, this last graphic I want to touch upon from the Dakota County study is one where they are comparing changes in total cyanazine frequency by year in concentration category from 2005 through 2019. So this is a great historical data set that the Dakota County has. So this represents 62 wells, all that have at least 5 samples each collected, though this does not have those 2 atrazine degradates included. So one interesting takeaway that I take from this graphic is there's a marked increase in that frequency of detection in categories above 50% of the HRL and over the HRL in 2019. So again, this chemical hasn't been used for almost 20 years, and we're seeing more instances of this being over that health risk limit for people who are drinking this water. So from this point on, I'm going to be focusing in on the MDA sampling results from 2019 and 2020, and then finishing with discussing our plans for 2021. So results come from over 1,200 samples collected in our surface water and groundwater sites. We have over 1,800 samples collected from our private well pesticide sampling project. We're going to look at 84 wells that we collected samples from that specific Dakota County private well project. And then finally, I'm going to end with an analysis of 2 different home water treatment systems. So in our surface water results, we had 759 samples analyzed for the cyanazine degradates in surface water in 2019 and 2020. So the diethylcyanazine acid was actually the only cyanazine compound detected in the surface water at a 15% detection frequency in 2009 and just 9% detection frequency in 2020. So on these maps that you're seeing, you can see detections are shown in the colored watersheds and the detection frequency in those colored watersheds. The maximum concentrations were quite low. We had just 104 nanograms per liter in 2019 and 118 nanograms per liter in 2020. So there are no aquatic life benchmarks for any of the cyanazine degradates for surface water. We do think it's interesting to note that all of these detections did come in western and southwestern Minnesota as you're looking at this map. So we suspect that degradates are coming from groundwater contributions to river-based flows in those areas. Now in our ambient groundwater program, we had 170 sites that were analyzed for the cyanazine degradates for a total of 445 samples in 2019 and 2020. So most of these are shallow water table monitoring wells in geologically sensitive areas or areas with agriculture and coarse textured soil. We have several sites with detections, which are shown here in the colored dots, and then the black dots are just locations where there was no, oh, I saw a question pop up, but maybe we'll just hold those to the end because it only showed for about 5 seconds. So I didn't even get a chance to read it all. So Mark, or if somebody wants to just keep those questions, I'll make sure to come back to them when we're done. So looking again at this, we had several sites with detections with those colored dots. So in total, in those 2 years, we had 4 springs in southeast Minnesota, 4 domestic wells in southeast Minnesota, and then 2 shallow water table wells in central. So there was only 1 total cyanazine concentration above the 1,000 nanograms or 1 microgram per liter HRL, and that was from Spring Creek Spring in Goodhue County. And so this has been the site, and that would be that red dot right there. This has been the site with the highest concentration from the Ambient network. And that's just a little over 1,000 nanograms or a little over that 1 microgram liter. But you can see that detection seems to be clustered in the southeast area, probably because in that spot, our monitoring represents deeper and older groundwater. Compounds detected included the cyanazine acid and the cyanazine, and then the diethylcyanazine acid in both of those atrazine degradates. Again, reviewing this data, generally cyanazine degradates have not been found in our shallow groundwater, which makes sense because this chemical hasn't been used for over 20 years. So now our largest collection of samples analyzed for cyanazine degradates involve our over 1,800 private drinking water wells in 39 counties, which was analyzed through our contract laboratory, WEC. And in total, from 2014 through 2020, we have sampled approximately 6,300 wells in 50 counties. So we have a big data set, but again, we only added those cyanazine degradates in 2019. So we only have that data for 2019 and 2020. So for the PWPS, this project targets areas with vulnerable groundwater and row crop agriculture. So blue squares are the townships where samples were collected in 2019, and those green squares are townships where samples were collected in 2020. On the map, detects below 1,000 nanograms are not shown, and the red dots show all of the locations where we were above the health risk limit. So in total, in those 2 years, we had 63 samples over the 1,000 nanogram total cyanazine HRL drinking water standard. Those included 17 in Scott County and 27 locations in Washington. Other counties include Olmsted at 4, Houston at 3, Chippewa, Moore and Swift right at 2, and then Stearns, Pipestone, and Goodhue and Wabasha at 1. So I did want to make a note that to say so these are all locations that are people, private water drinking wells. So when we've collected a sample and we get results back that indicate that anything is even 50% of a reference value, we contact that homeowner so they know what's going on. And we also ask to take a verification sample. So those verification samples have just helped us make sure that the contract lab was spot on. I mean, we've had a few instances where there's been issues, but those verification samples, so we'd actually take one that would go to the contract laboratory again, and one that would go to the MDA lab. So these locations actually all have 3 sample results that are associated with it now. And for the most part, the majority of them all continued to match very well and to indicate that this was over at least 50% of an HRL, if not over it. So again, we are always taking into account that the fact that this is something that people are drinking, and we're trying to let people know as soon as we can if their well is impacted. So I want to explore a little bit more about 2 of these PWPS counties where we saw those highest numbers of wells over the HRL. So first off, I'm looking at Scott County. So this figure indicates where all the PWPS townships have been sampled from 2014 through 2020. This call out is showing the townships in Scott County where the PWPS samples were collected, and this was in 2019. So overall, in 2019, though, we looked at 23 counties for a total of over 1,100 samples. So specific to Scott County, we know that they have sandy and superficial geology and karst bedrock. And when you combine that with high amounts of ag land use, it makes these wells in these specific areas, especially the shallow wells, pretty vulnerable to contamination from ag chemicals, including pesticides. So when we looked even closer at those 4 townships in Scott County, you can see up in this right-hand corner, only Jackson and Louisville townships had locations where the total cyanazine was at least half of that HRL. So as I mentioned, there were 17 locations that were sampled in 2019 that were over the HRL, including 4 that were actually above the acute HRL, which is of 3 micrograms per liter. And the degradates were detected in 43% of the 91 wells tested. And the highest total cyanazine concentration found was actually at 10.51 micrograms per liter, which is 10 times the HRL. There were no other pesticide reference values exceeded in Scott County. So now looking at Washington County, this was one of 16 counties with townships tested in 2020. That year we collected 738 samples collected. So this is very similar to Scott County. We have sandy superficial geology, karst bedrock. You combine it with that high amount of ag land use, and it just makes these shallow wells very vulnerable to contamination. But here we're just looking at the very southern part of Washington County. And as we zoom in a little bit closer, we know that the cyanazine degradates were detected in 67% of these 99 wells tested. We had then, again, like I stated, 27 wells that were above the 1.0 HRL, and 8 were above the acute. The highest total cyanazine concentration found was a 6.2 micrograms per liter, which is 6 times the HRL. But again, total cyanazine was the only pesticide reference value that was exceeded in Washington County. Now to go back to also Dakota County, I mentioned that we had offered sample collection to private well owners in Dakota County that had had previous detections of cyanazine degradates. So if you remember just a few slides back, I was talking about how Dakota County had this big data set, and we right off in 2019, we were just getting the method established. So we wanted to go and basically do a, not a round robin, but we wanted to offer our lab, the WEC lab, and then also the USGS lab. We wanted to take samples through all 3 of those labs and then compare results and see how things kind of lined up across the board, which would give us a really good understanding of the historical nature of what the USGS had collected. So we sent out letters to approximately 140 locations where cyanazine or its degradates had been detected, and we got 84 sites that said yes, and so those were the spots we went to. So we did split sampling at some locations, split sampling at all the locations, and then several locations got triple splits. So we sent all the lab sample, or all 84 went to WEC, 46 samples went to MDA, and then 41 went to the USGS. But unfortunately, we collected the samples, we sent the samples, but before analysis could occur, the USGS equipment failed, and they made a business decision not to want to get new equipment. So that method, they're no longer running it. So we did not get that great kind of analysis of looking at all 3 labs. But we still had the 2 labs, and we found that things lined up pretty well. We did have WEC show that their maximum result was over a 4,700 nanograms per liter for that diethylcyanazine acid. But generally, as we looked at the results and compared the labs, MDA and WEC, things had pretty good agreement for the locations where we had split samples, those 46 locations. And we also felt that looking at the historic Dakota County data, that things lined up pretty well. There wasn't many that we were like, oh my gosh, this looks really strange. And in total, we had 14 sites that were over that 1,000 nanograms per liter. And similar to what I showed in the ambient reports, most of the higher findings were again centered in those 3 townships of Vermilion, Marchand, and Nininger. So switching gears a bit, I want to discuss results from our work that we looked at pre and post water treatment in private water systems. So we collected 54 samples from pre and post treatments of private water systems from 2017 to 2020 that use reverse osmosis treatment. So shown here is just an example of what a reverse osmosis system looks like. So the RO had great results. So on average, reducing pesticide concentrations by 99.7% and nitrate concentrations by 79.1%. So those pre-treatment total pesticides range, so that's over 160 different pesticides that were looked for. Those ranged from 270 to over 11,000 nanograms per liter. And once it had run through the system, the post-treatment total pesticide range was from non-detect to 153. But the best news was all cyanazine degradates were removed from the samples that we looked at from the 2019 and the 2020 sampling. So great news for that. There is this option for well owners about reverse osmosis as a possible treatment. Now, we also did look in 2019 and 2020, we looked at activated carbon filter treatment systems. So we only looked at 11 of these. So again, not a big data set. I totally get that. And I'm going to say, let's not hang our hat on any of these results, but because we had them, I did want to share. But we did feel like the pesticide removals were mixed. So looking on the left, 7 of these systems that we're calling well-performing averaged a total pesticide reduction of 96.7%, which, that's pretty good. But there was 4 systems that we're calling poor-performing, and their total pesticide reduction was 10%. So the well-performing systems generally were newer than the poor-performing and had recent maintenance completed. But the results from this evaluation suggest that properly maintained activated carbon filter systems may be effective at removing pesticides from this private drinking water well. But we just haven't reviewed enough of these or evaluated enough of these that we would want to say for sure, yes, go ahead and get this type of system. So no other guidance will be coming from us on that. This is just more of like, this is what we saw. And, we would, if someone was asking us, we would say a reverse osmosis has continually provided a better performance than what we saw with this activated carbon. So general summaries then from the monitoring work from the 2019 and 2020 include that total cyanazine is present in vulnerable drinking water wells in ag areas in Minnesota at concentrations above the established health risk limit of 1 microgram per liter. And this is indicating some long-term persistence. Now we had, when you add them all up, we had 77 wells that were over the HRL in 2019 and 2020. So to give a little bit more perspective, when we look at all of the PWPS wells from 2016 to 2020, we had only 4 other wells that had 4 other separate pesticides that were over a reference value. So 77 for total cyanazine in a smaller data set, and then in a bigger data set, over 6,000 wells. You take out total cyanazine, we only had 4 that were over a reference value. The D-ethylcyanazine acid generally dominates among these cyanazine-specific degradates, both with respect to concentration and detection frequency. Management options are limited because the parent cyanazine is no longer used. Countrywide, I think there may be areas besides in Minnesota that probably need to be investigated in their deeper drinking water aquifers to see if they too might be having some issues. We have found though that homeowner maintained point of use reverse osmosis water treatment systems were quite effective at reducing total pesticide concentration, including removing all of those cyanazine degradates. Now, for the rest of the presentation, I'm going to focus in on what we're going to do in 2021. So I want to talk just briefly say thank you with the help of a work group. So we have staff from Department of Health, Department of Ag, and Dakota County. We have met since, I think, early fall of 2020 to talk about results, talk about suggestions, lay out monitoring plans, review plans, look at this RFP. They've been very helpful. And I think it's great to always be able to involve different agencies, especially when this is a problem that's not just specific to one location, it is statewide. So what we did is we had a request for proposals that was sent out in January 2021. So we're looking for a contract laboratory to run just the 10 analytes specific to cyanazine, atrazine, and associated degradates. Our MDA lab just cannot take the sample capacity of any of these private well samples. So that's why we need to find a contract laboratory. And we wanted to be very specific because we have already went out and collected pesticide information, but we had not gotten these cyanazine degradates. So that's why we were really focusing in on these 10. So we hope to begin our private well pesticide sampling project, phase 2, what we're calling it, in June, though it all depends on contracts. You know how that goes. So we'll be offering samples to homeowners who have been previously sampled, but that, like I said, did not include the cyanazine degradates. So we have over 3,600 wells, though, that haven't received those cyanazine degradates. So as you can see from this map, we have locations in all these different townships that have not received those. And on average, one hydro could probably collect approximately 400 samples in a full season. Well, we're not even at a full season anymore because that would be like starting in April or May. So we needed to find a way to prioritize where we should look first. So our group started out first by looking at a variety of data sets. So this is a data set I alluded to earlier that talked about well depth. So note that this data is for well completion depth and not well casing, which is what I had shown for Dakota County earlier. But so looking at over 660 wells in Southeast Minnesota, where we have collected samples that have been analyzed for cyanazine degradates, you know, the first thing to point out here is, oh my gosh, how many wells don't have depth information? So over 400 of them. So right off the bat, this data set is not exactly as robust as I would like. So please, I mean, again, these are not, it's just not as robust as I would like to be laying out, basing firm conclusions on what we're seeing here. So, I mean, the main takeaway here is that it does look like total cyanazine concentrations tend to be higher in the deeper wells. I think we already knew that. So this graphic didn't really help me in trying to really prioritize where we're going to look. So here we decided to look more, let's look at the aquifers. So now we looked at 43 wells with total cyanazine above the HRL that did have well logs with aquifer information. So we looked at about 10 different counties here. And what we saw is that the high cyanazine, total cyanazine wells tended to be in the Quaternary, the Jordan, and the Prairie du Chien aquifers. But even knowing that, we still have a whole lot of wells that fall into that category. So it still didn't help us determine where we should go. Well, one of my colleagues, Ben Bruning, spent a lot of time looking at different pesticides and possible co-occurrence with cyanazine degradates. And I won't go into a lot of that work, but I'm going to focus in on what we did find was with the DEDI, or the diethylatrazine, that came to the top. So this chart right here indicates several things. So first, that first column right there shows us the total number of wells tested for that cyanazine DEGs in each of those counties in 2019 and 2020. Then we looked at, well, how many of those wells have a total cyanazine concentration that's at least 0.5 micrograms. So looking at that data set, then we said, well, how many of those wells that have at least 0.5 micrograms per liter total cyanazine also had detectable levels of that DEDI atrazine? And what we saw is that almost all of these counties, it was a 100% probability that if a well had DEDI in it, it would also contain higher values of total cyanazine. So what is key about this is that in our previous sampling from 2016 through 2018, we have DEI results. Now, I'm going to say there's a lot of caveats here. This doesn't hold up well in the central sands, mainly because we did not find nearly as much locations that had higher cyanazine degradates. So we tested 589 wells for cyanazine degradates in the central sands between Benton, Morrison, Sherburne, and Stearns. And in those locations, we only found one cyanazine detection over the reference value. So this is a work in progress, but we thought this could be really helpful in helping us this year as we consider where to go to look for top priority. So we had 1,900 wells then that had been sampled previously in 6 counties in southeast Minnesota. So then using that didecylatrazine data, we excluded wells that were non-detect for that. And we got to what that total is at a little over 1,000. And then basing on a potential response rate of 70%, which now we're thinking that's probably really hopeful, but hey, who knows? We're thinking about it'll be approximately 814 wells that we'll be sampling. So we do plan on completing the sample as much as we can this year and then going back and picking up sampling in 2022 because we just don't think based on where we're at in the calendar year that we'll be able to get all of these samples collected this year. We do also plan on establishing a long-term cyanazine monitoring locations in 2021. So we'll be starting out with 5 wells this year, but hopefully growing it to maybe 15 or even 20. It all kind of depends on what we're finding in these each coming years, but for sure at least 15. So we're looking for good spatial representation, definitely locations that have well log information, and then we want to have previous results that are over at least the 1 microgram per liter. So we hope to have at least 1 location in Dakota, Washington, and Scott counties, because again, we know that those are areas that we're seeing higher total cyanazine concentrations, and we want to see what's happening over time. You know, is this continuing to go up? Is it going down? I think having some of these wells similar to what Dakota County has to be able to track what's happening over time is really important. Again, this map is just showing the potential though. Until we send the invitation letters, we don't know who's going to want to do this, who's going to want to sign up. So thank you so much for listening. I'm going to wrap this all up now and then we'll have some time for questions. So we are sampling in southeast counties where the data suggests the highest risk. We've selected the counties of Rice, Goodhue, and Wabasha to start with first, since they were the closest to the other clusters of higher findings that we've had in Scott, Dakota, and Washington. So the new analytical method, we're going to focus in on just the cyanazine, atrazine, and associated degradates to help reduce costs. We're also are going to collect a nitrate sample at all these locations, and we are partnering with the Minnesota Department of Health to collect cations and anions at all of these locations as well. Our target sampling goal is about 700 wells a year, so depending on when we start, that might not happen. And then we are going to plan on sampling other counties and hotspots in future years. I'm currently working on a 5-year sampling plan, trying to, based on the data we had historically and what we're seeing now, trying to map out where we think we're going to try and go each year. So funding for this project was provided by the Minnesota Clean Water Land Legacy Amendment and Pesticide Regulatory Account, which are fees paid by pesticide dealers and users. I have several links there. We have a website about cyanazine monitoring on our website. We also have, you can see all of our results from 2019, our water quality monitoring report. We have a full cyanazine section within that report. And the 2020 report hopefully will be posted up there as well by July. And then we also have the MDH website, which has a fact sheet for private well users that goes through items such as potential health effects, how to protect your family, treatment options, and then what the state's doing. I just wanted to acknowledge there's too many people to thank, but lots of help from staff on making this presentation. But I mean, this takes this is a full effort. We have hydros out in the field, we have lab personnel, we have staff in the office who do the data analysis. So everybody plays a really important part, and I just want to thank them all, and they are listed there. And with that, I have talked for way too long, so I am done, and I'm happy to take some questions.
Great. Well, thank you, Heather, for your presentation. We do have a couple questions in the chat, so folks feel free to add any additional questions you might have, or once I'm done running through these, you guys are welcome to just unmute and ask Heather your questions directly. So the first one we have here is there an explanation as to why diethylcyanazine acid is the only degradate found? Is that degradate different in characteristic from others?
Oh, that's a good question. I think we're still learning a lot about these chemicals, and I don't have a great answer for why that's the only one. I think they're maybe talking about surface water because other of the degradates have been somewhere else. But I think as we continue to collect samples in our surface water, and as we continue to perhaps move some of our groundwater sampling to collect in that kind of area where I was showing that we were also seeing findings in surface water, we'll maybe learn a little bit more. But I don't have a great answer to say why is it only the diethyl.
Okay, great. Thank you.
Stop me right away. Come on, Dean.
All right, maybe this one will be easier, I think. Are these degradates bioaccumulative?
Well, as you see, we sum them up to get to that. If they're talking about bioaccumulative and saying, I'm trying to feel like what concept are they saying? I mean, we sum them up to get kind of a total result to give us that total cyanazine. So they accumulate that way, but I'm not sure in terms of another way that they're asking. Yeah.
If Verlin is still out there and wants to clarify if she's answered your question or not, please feel free to jump in.
Yeah, the best thing I can say is that, alone, I don't think many of these degradates would be a concern. It's just the fact that we do add them all up together based on the guidance from Department of Health. And that's where, I really think it's the diethylcyanazine acid that's really driving that. For the most part, the rest of those results are usually quite low. So there is that to contend with.
So I think they were, they clarified here on the question is, do they leave the body? So is it similar to mercury where it builds up and doesn't leave the body as you kind of continue to ingest it over time?
That would be, I'm more of the water person. That one seems like more of a question for Department of Health, but that is a good question. I can follow up with you, but I do not know the answer to that one either.
Okay, thank you. So here's another one. Is EPA aware of these findings? And if so, what have they communicated to MDA about it?
Well, we do have yearly meetings with EPA, so I know they have been told about it, but in terms of anything specific back, no, I have not heard anything. I mean, and I think, last year we got these results and we were anticipating there'd be some more discussion about them, but then COVID happened. So I feel like Cyanozine, in terms of, getting a lot of word out, it's been very quiet, but such is why I'm trying to do a little bit more pushing out now of this information, because we do think it's important that people know what we're finding. And I continue to look for avenues of ways to communicate what's happening and what's being done. But, we have our reports. This information all goes in through Equus, so it is available for anybody to pull out. So anybody could be looking for it. We have talked with USGS because they were aware, because we were doing that joint project with them. So they know what's been being found. So definitely people are hearing about it. I actually just spoke at a national conference yesterday to talk about cyanazine as being a chemical that people aren't on people's forefront. So continuing to try and get that word out, but I think it still seems pretty quiet.
Great. Another question here is, do you know of any other states that are planning to investigate cyanazine degradates in their water resources?
No, but then that's again where I'm trying to continue to get this word out. That was one of my takeaways yesterday at that national conference, was just we'd like people to consider adding this on to their instruments for especially pesticide agencies such as ours that have their own lab. Those standards are now available, the method is available. So it is something that could be added on, especially in those areas, if you guys remember that map that I was showing where we know use was really heavy. I think it is something that other states should consider, such as Wisconsin, Iowa. I mean, we did have a meeting last year with the Wisconsin the sampling group, kind of what mirrors what our group is. And we told them all about this information. But what we always hear is that our program is one of the best programs in the nation. So we do a lot of pesticide work that many other states do not. So I think that helps us in the forefront. But again, you know, kudos again to Dakota County. We weren't looking for the cyanazine degradates either, because there is something to be said of when something is not registered. We know it's not being used. There's so many chemicals we're looking for. We simply can't look for everything. So sometimes it's a problem of we don't know what we don't know. But now we do know about cyanazine degradates, and we're trying our best to continue to investigate.
All right, we have, it looks like one more question in the chat. It says here that, oh, we have two more, okay. Does the continued use of atrazine in the karst regions in southeast Minnesota give values above the HURL pose a risk to human health?
Well, I think, you know, if there's samples that go above the human health, and yes, that is a concern. I think, are they talking about, I wonder, in terms of with cyanazine, like I said, we only use those degradates if there's also any cyanazine degradate in that sample to kind of give that full total cyanazine results. But I mean, I think anytime something is over a health risk limit, there is concern. But in terms of human health, like I said, we, in that private well pesticide, you know, so we've looked at things for 6 years. Total atrazine was never one of those four chemicals, one of the four other chemicals that was over a total reference value. So it's just been those total cyanazine, and that was four other chemicals up. And I just saw Brennan put up that total cyanazine is at 3 micrograms per liter. So I think following the label and correct usage, at least in our sample set here, is showing that that total cyanazine is not being found over a reference value in people's drinking water, but total cyanazine is.
Okay, yep, and it looks like we've got some comments in the chat as well that are helping explain that.
Thank you, everybody. I don't have the chat open, so.
Yes, so you should be able to actually on the far right of bottom of your screen, you should be able to click open the chat.
Oh, there we go. Sorry.
Yeah.
I'm just gonna...
No problem. I'm happy to facilitate the questions.
Thank you.
So I think we got some good clarification. And then there is another question here from Roberta. Is there any evidence and efforts to look at whether certain conservation practices help to reduce concentrations?
Oh, I mean, that's like a whole other talk that we could go into. But in just the realms of the focus here being total cyanazine, I mean, no, like this, because it's not being used, there are no management options that we can offer to help dissipate any of this. I mean, really right now for us, you know, we can monitor it, and then we can let people know what's going on and be in communications with Department of Health, talking about people's health risk, about what's happening. But in terms of any conservation practice specific to cyanazine, there is not.
Okay. And then it looks like we've got a few extra These are just comments again on those HRLs from some of our very knowledgeable participants here. It's great about these, as we always have different expertise in the audience that can often help out. So this is from Sarah saying that the HRL value is outdated, but in general, they are values where we consider the concentration of a contaminant to be of low risk to a person consuming the water. And then Brennan has just a description here of what total atrazine is. All of the different compounds, and I'm sure I will not pronounce them correctly, so I'll let you all just read them.
Yes, it even stumps us some of the days, and we spend a lot of time talking about these chemicals.
Right, and I do not. My chemical is chloride. That one's easy. It rolls off the tongue real easy. So.
Oh, well,
All right.
I mean,
well, I don't. Oh, go ahead, Heather.
No, I was just going to say, I really appreciate everybody listening into this talk. I do think cyanazine is, it's out there, and I mean, we definitely are seeing that it's in people's drinking water, and it's over that health risk, the health reference level that people have been drinking. So it's a concern. So we are doing our best to continue targeted monitoring to see where else it is and to get that information out to the public as soon as we can.
Yeah, Heather, that was really an interesting talk. You know, it strikes me, together with what Jill Trescott presented to us earlier, you know, together with your work, if nothing else, you know, this shows all of us just, it's such a great lesson in how long we can detect contaminants after something has stopped being used. And just because we don't even see the parent compound doesn't mean that the chemical can't be found in its degradation products out there somewhere. And you know, it's pretty sobering news at how widespread you can find these contaminants out there still. You know, it's stunning to me, actually, the extent to which you can find these degradation products. I'm kind of wondering, do you see anything like that in other pesticide data where you see these degradation products, apart from cyanazine, persisting after, you know, decades after the parent compound was discontinued?
Well, I mean, for the most part, we are just monitoring present use pesticides. So, I mean, I know we have Alachlor, which but we are continuing to use because that just recently stopped. But for the most part, again, you know, we only have so many resources. So the concern is what's being actively applied, because that's, you know, that's what we want to know, is that running off into the streams? Is that in the groundwater? But I do think it kind of begs that question. What are we missing? Are there things that have been used in the past that we should consider looking for? But as you all know, it's expensive to do pesticide monitoring. The equipment is running about $500,000 or more per piece of equipment, and our lab is fabulous, but as anybody, our equipment's getting older. And so, you know, it's this push-pull of like, well, how can we do what we need to do? How can we look beyond that? And still try and maintain that sample capacity, that lab capacity. I mean, it can be difficult. So that's a great question though, Mark. I do think there's opportunities to look for other chemicals, but it all depends on a wide variety of factors.
All right, well, we do have just one comment here from Jill on another Alachlor ESA seems to be diminishing much faster than the cyanazine degradates. Well, everybody has there's all kinds of comments in there about your wonderful presentation and what a great job you did. And thank you again for joining us today and sharing your work and helping us all better understand this issue. And we really appreciate your time today and all the work that it took to prepare that wonderful presentation to share with us. So thank you for
Yeah,
that.
yeah, certainly really, really interesting data, and thanks for putting it together and telling us about it. It's great.
Yeah, well, no problem. Thanks for listening, everybody. Much appreciated.
On June